Now we're going to learn how to find the zeros of polynomial functions, which graphically speaking means the x-intercepts of the polynomial function. Alright, so let's start out with some definitions. So if we have f of x is a polynomial of degree n, where n is positive, then f has at least one zero in the complex number system. And with the linear factorization theorem, that says that if f of x is a polynomial of degree n, where n is positive, then f has exactly, precisely, n linear factors, where c1, c2, c3 are complex numbers. Okay, so what does all that mean? In plain English, the number of factors a polynomial has is equal to the degree of the polynomial. If you have a second degree polynomial, you'll have 2 factors. If you have a 10th degree polynomial, you'll have 10 factors. So how do we know where to start? Well, luckily we have this thing called a rational zero test. And what it says is if you've got a polynomial and it has to have integer coefficients, okay, then every rational zero of f has the form of p over q. Okay, what's p, what's q? P consists of all the factors of your constant, and q is all the factors of your leading coefficient. Now, this only helps you find rational zeros. This polynomial may not have any rational zeros, and in that case, none of these are going to work out. But at least it gives us a list of numbers to start with. Okay, and finally we have one other little helpful tidbit of information here. It says that complex zeros occur in conjugate pairs. What that means is if I know that a plus bi is a zero of f of x, then I automatically am guaranteed that a minus bi is also a zero. So if you've got a polynomial with real coefficients, if they have complex roots or complex zeros, they always come in twos, and they come in conjugates. So let's put these two theorems to use here. We're going to list all the possible rational zeros of this 4th degree polynomial, and then use that list to determine all the actual zeros of f. So we're going to start with the possible ones and then test them to see if they actually are. We're going to do synthetic division. So I'm going to get p is my list of my constant factors. That's going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Q is my list of my lead coefficient factors, which is plus or minus 1 and plus or minus 2. Alright, so what that means is P over Q will be 1 over 1 and 2 over 1, 4 over 1, 8 over 1, 1 over 2, 2 over 2, well that's 1, we already have that, 4 over 2, that's 2, we already have that, and 8 over 2, that's a new one, that reduces to plus or minus 4. So I have all these numbers that I can test. So let's try 1. Okay, I'm going to list my coefficients up here. So I've got negative 2. Let's get a little better look of it there. Negative 2 and 13, negative 21, 2, and 8. And I'm going to move my 1 down here. Okay, so remember I'm going to do my adding in my head. So I bring down the negative 2. Negative 1 times negative 2 is negative 2, plus 13 is 11. 1 times 11 is 11, minus 21 is negative 10. 1 times negative 10 is negative 10, plus 2 is negative 8. And finally, 1 times negative 8 is negative 8, plus 8 is 0. So we lucked out. We know that this is a 0. Okay, now another number on our list is 2. So let's try that. And I'll work with my reduced polynomial here. So I bring down the first coefficient, negative 2. 2 times negative 2 is negative 4. Plus 11 is 7. 2 times 7 is 14. Minus 10 is 4. 2 times 4 is 8. Minus 8 is 0. And we lucked out again. Actually, we didn't. I knew those were going to work ahead of time, but in the interest of time, I didn't want to waste half the screencast testing numbers. Okay? All right, so remember that we started with a 4th degree, then that dropped down to a 3rd degree, and now we're at a 2nd degree. And once I reach that spot, I can either factor or use a quadratic formula. And I believe this will factor minus 2x minus 1 and x minus 4. Okay? That'll be minus 2x times minus 4 is positive 8x, and then minus 1x gives me 7x, and negative 1 times negative 4 gives me 4. Yep, that works. Okay, so here are all the zeros. X equals 1 from up here, remember. 2 from right there. 1/2 from right, negative 1/2 from right there, and finally positive 4. 4 zeros, 4th degree polynomial. All right, my last example, we're given a complex zero of this function, and notice that it has rational coefficients. So if 2 plus I is a 0, then I automatically know that 2 minus I is also a 0. Okay, so let's put 2I in our synthetic division box, and I want to write the coefficients, not the polynomial. That's going to be 1, negative 1, 4, and negative 4. Bring down 1, 2I goes in there, and I get negative 1 plus 2I. Okay, negative 1 times 2I is negative 2I, and 2I times 2I is 4I squared, which is negative 4. When I add that, I get negative 2I, and 2I times negative 2I is negative 4I squared, which is positive 4, so we get 0, which is what we expected since we were told that was a factor, or a 0 rather. Now let's try our other conjugate 0. Bring down the 1. Negative 2I added to 1 plus 2I gives me negative 1. Negative 2I times negative 1 is positive 2I, which gives us 0. Okay? So here's our final factor, x minus 1. So that means that x equals 1 and plus or minus 2i.